Welcome to our channel Euclid Mathematics. We have started lecture series on JEE Advanced Previous Year question paper. Within that, I already uploaded plenty of the videos on my channel. So if you are new here in my channel, you may check all my videos from playlist. You will get the plenty of the videos on my channel on each and every topic. So even after, if you want to see any other difficult topic, if you wanted to solve any difficult question or understand any topic, let me know in comment section. I'm gonna explain that topic question in my video in my channel. Okay, so in my today's video, I'm gonna explain to you all one of the JEE Advanced Previous Year question paper. Now let's get start our question. First of all, I'm gonna explain to you all the question, and then we'll go for the detailed understanding of solution. So here in our question, we have given omega. Omega means already we are familiar with the omega. Omega, which is a complex cube root of unity. Okay. So we have given omega which not equal to 1 be the complex cube root of unity. Only cube root of unity there. Okay, that means it is a complex cube root of unity. Then we want the minimum value for a modulus of a set. Okay, so we have given one set under modulus a plus b omega plus c omega square bracket square such that ABC are distinct non-zero integer. Okay, ABC distinct non-zero integers are there, and W is a complex cube root of unity. Okay, and then we have to figure it out what is the value for that question it is coming. So the question, it is no answer type question. That means we have to find out the required fill in the blank over here. Okay, so we do not have option here. So question, it is quite easy from the complex numbers chapter. Okay, so very easy that we have to find out the fill in the blank. And the condition which is given in our question for ABC, which is a non-zero integer and a non-zero integer, and we have to take that positive non-zero integer. Okay, because whenever we take the negative non-zero integer, this value collides with the complex values. Okay, because the complex numbers value, because iota define the value for a negative of 1. Okay, so which is the value for iota, so that mostly this value collides with the complex values. So that's why we have to consider positive value here for solving this example. Okay, now let's get started on today's solution. We'll go for the detailed understanding of solution. So we do not have option here, so we have to find out directly the answer. We have given omega not equal to 1. Okay, so we have complex cube root of unity. So what is the complex cube root of unity? The value for a root. Okay, complex cube root of unity, we have the value for omega square and omega here, omega to the power 1 and omega square. Okay, and the complex root of unity having 3 roots here. Okay, these 3 roots, first is a 1, another is a minus 1 plus root 3 by 2, and another minus 1 minus root 3 by 2. Okay, these are the 3 roots of our complex cube root of unity. So these are the 3 roots from the complex cube root of unity, but within that we have given omega which not equal to 1. Okay, so this option is discarded here, so we cannot consider that root for our solution of example. Okay, so we have to delete this one as the part of question it is given. Okay, so we have to consider these 2 values, and then we have to find out the fill in the blank. Okay, now here we can see we have to find out the value for set modulus of a plus b omega plus c omega square bracket square into a and abc are such that abc are distinct non-zero integers are given. Okay, abc distinct non-zero integers are there, and omega be the complex cube root of unity. Okay, so if omega is a complex cube root of unity, so we have here 3 roots for omega here and omega square here. Okay, so now put this value omega and omega square in our modulus. Okay, so here we can see a keep as it is, b as it is, c as it is, omega from here, omega square from here, and modulus square. Okay, now here we can see the values a plus b omega plus c omega square, a plus b omega, so omega it is coming from here, plus c omega square it is coming from here. Okay, so this is the value for omega square here, and modulus square it is already there. Okay, so this is the value for omega square. Okay, don't get confused. So now we have to go for the further calculations. Okay, so we have to find out the expanded form of our a plus b plus omega plus omega square. Okay, just go for the calculation. Take the, first of all, take 1 by 2 common from there. So after taking 1 by 2 common, so will remain the value 1 by 2 common from here, 2a plus b under bracket minus 1 plus I root 3 plus c under bracket minus 1 minus I root 3 bracket complete bracket square. Okay, now 1 by 2 common here. Now we have given 1 by 2 over here. Okay, modulus of 1 by 2, the modulus doesn't affect on our real number, positive real number. So 1 by 2 it is taking out, then we will get the square of 1 by 2 is 1 by 4. Okay, now remaining part over here, how can we find out the modulus for complex number? Okay, now let me explain with some short example. So if you want the modulus for complex number like x plus iy, okay, if I consider I'm having z is x plus iy, and I want the modulus for this complex number, like a modulus of z is equal to modulus of x plus iy. So for finding the modulus of this complex number, what we do? We take under square root first element square plus second element square, but not y square. Okay, this is the representation of a complex number. We cannot operate over here. Okay, so modulus of z can be written as x square plus y square. Okay, so this step we have to apply over here. Okay, so after applying this step, or you may go for the calculation. So 2a minus b minus c at close I times b I times root 3 under bracket b minus c bracket square. Okay, so I taken just element common from here. So 1 by 2 square is 1 by 4 here. Okay, 2a minus b minus c bracket square plus 3 by 4. Okay, so 1 by 2 here, that means 1 by 4, and that 1 by 4 it is also here. Okay, root 3 square means 3, and b minus c bracket square. Okay, I taken directly square because it is applicable over here, but sometimes you cannot apply directly. What you need to do, you have to take x plus I times y, their modulus, find out modulus, multiply 1 by 2 and find out square. Okay, now where that I gone? Okay, now let me explain one more time here. So for that I, so what we have here, the condition x plus iy. Okay, that means x plus iy, that means modulus of I it is coming here, the modulus here, the modulus here plus modulus here plus modulus here. Okay, so we have here modulus of I, and what is the value for modulus of I? So modulus of I can be written as 0 into x plus 1 into I into 1. Okay, what I have done, I written I as a 0 into x plus I into 1. Okay, now I want the modulus for I. So modulus for I means x plus iy. X is here 0, y is here 1. Okay, x plus iy. So x here 0, y and y is here 1. Okay, so take square root of x square plus y square, 0 square plus 1 square. Okay, so square root of 1 square. Okay, it only coming 1. Okay, so I got the value for modulus of I, which is a 1. Okay, so that's why I removed that I from here. It is very easier to understand, nothing is difficult here. Go for the expanding the term 1 by 4 as it is, a minus b minus c bracket square, expand this term here, plus b minus c, expand this term here. Okay, after calculating you will get this term. This is just expansion of a polynomial, like a square minus twice of ab minus b square. Okay, this way you have to solve. After solving all these steps, you will get the a square plus b square plus c square minus ab minus bc minus ca. Okay, I'm not gonna explain this step because these are the just calculation. You have to find out the square for polynomial only. Okay, once you're going to follow the next step, you will land on this step only. Okay, now what we have given, abc, we have condition on abc be the minimum value for our polynomial. Okay, which is a integer, non-zero, positive. Okay, now tell me the positive non-zero integer, positive non-zero integer and the smallest. Okay, it is given in condition, positive non-zero integer and they need to be a smallest. Now, and all need to be a distinct, that means all abc are different than each other. Okay, all are distinct. that means smallest positive, that means it can start from smallest number 1, again smallest number more than bigger 2, more than 3, and so on. Okay, and we want the non-zero, zero do not want, negative number do not want, but integer we want. That means smallest will be first number, we can take 1, all need to be a different, that's why you cannot repeat 1. Second we can 2, and third we can 3. Okay, so we got the 3 numbers. Let's consider these numbers here. Okay, as I did here, I consider a is a 3, b is a 2, and c is a 1. Okay, I consider a3, b2, c1. Why I consider abc these choices? Because we want the positive non-zero. It is a non-zero positive and the smallest integer. It is not like a fractional or any other number. Smallest number we have only possible smallest distinct number 3, 1, 2, 3, only 3 number. Okay, that's why I selected these 3 numbers. It is not given in question, but the condition is given that can be applicable for this number. Okay, so a3, b2, c1 I consider here. You may say take the any order. Okay, so put this value abc over here. After substituting this value, you will get the answer 3. So the required answer for our question, which is a 3. Okay, so it is a no answer type question, so you have to fill the blank. So to fill that blank, you have to find out the answer, that you cannot sure what answer you will get. So even after, if you get the 3, 4 answer, 5 answer, your answer will be wrong there. You get the excuse for 0.5 points. Okay, that means you can get the value for 3.2, 2.9, like this, your answer will be correct. Okay, but I don't think so is anything difficult in our question, that we have to apply the condition which we have given in question. Okay, nothing is difficult, nothing is more conceptual based. It is easier, just calculation based question. Okay, I hope you all have understood my today's question. But even after, if you found anything difficult, let me know in comment section. I will come up with some other videos. So thank you everyone, thank you for my today's lecture.